Hello everyone, welcome to my channel. Today we will continue with the Schneider Unity Pro programming part 2. In this part we can discuss more on derived function blocks, and we will see how to import and export the functions and how to use the simulator and test the logics, and also we will see today how to configure the local, remote and distributed IOs. Derived function block is very important tool in reducing the working time of a programmer for creating a repetitive types of logics. Example, pumps, valves, this type of things we can create one time, and you can use the same block in many places. Now we can create one DFB blocks. Before we are creating the DFB blocks, first you need to create the derived function types. Just click the derived function type, and here you can add the functions. Example, I will create now one pump. In these pumps, see, once you created in the derived function types, example I created as a DFB, you can see here it will be automatically created inputs, output, input, output, public, private, sections. If you open one by one, you cannot find anything currently at initial stage. So you need to first note that for one pump, what are the signals you need to be add. Example, before you are creating one pumps, you need to first understand what is pump and what are the signals you need in pumps. Example, first you need one pump remote or pump auto as input, pump underscore manual, pump underscore run. I will make one small application, pump underscore trip. So all the functions type is boolean, and for output what you are going to control, you are going to control pump underscore start command. If you need, you can put stop command also, but it is not necessary. And other than this, if you need to add, you can add example pump runtime or pump auto sequence or some other logics. But currently I will make one small application with small pumps, so I can keep with this one. And for input output, if you need, you can add for input output. For time being we will not add, but later on we can add during the execution time. Now for the public, you can add the signals which is not used in input or output, but it can be used inside. This one also we can see during the creating time. So just I will save this application. Once it's saved, you can utilize now the pump section, give new sections, and you can create the pumps in 4 languages: structured text, instruction list or function block diagram, and ladder logic. Which one is easy for you, you can make the logic as per that. For me I can use function block diagram, and inside I can give the name pump also. You can give any name, because here in the outside folder, outside derived function types, I given pump, and here also I given pump. It will not affect. If you need, I can put pumps type 0 or pump type 0. So I can use like many types of functions. If you need to make the protection, you can give the protection read only, no read and write. This one we can see later. give apply and OK. See here it is informing that you cannot use the underscore, so I can give, see already it's created, sorry, pump underscore type 0. Double click and here you can create the logic. See I can use here, see here data selections. If you not known which function you are going to use, see right click and you have data, see FFB in input assistance or data selection, double click. Example, I am going to use OR function. If you type OR, it will create OR automatically. If I just right click, see here we have two options. One for data selection, you can just go there and type which data you need, example add, and right click, it will up, you can give add. See, if you are selecting here FFB, click and go to browse here, it will go to the function library. Okay, in this library you can find the same functions, and or if you not know this function, you can browse from here and you can search which one you need in your logic. Okay, so you have all the functions here. Here this is for array, and you have comparison, date, time. If you need to see all the functions, click here, you can find all the functions here. So you can just, example, I will add one timer. If you don't know, just type here or you can search from here. In the custom, mostly you can what are the functions basically you are using, and you can importing, it will become in under the custom library, which one you have created by yourself. This in the basic library you can find all the basic types. Yes, you can use the timer, counters. If you type .t on timer, just click and give here and paste, so you can find the timer also. So what you are creating here, just you need to browse and add your inputs which you created earlier. Example, now if you need to add in the block for auto, give auto, and you can give no manual, so you added manual, but this is auto, and or this logic is for OR gate. OR gate, it should be any one. For AND gate, it should be both should be positive or negative to execute the logic. So for OR, if any one it's there, it will be operate as one. Example, if the auto is there or there is no manual, here you can use negative pin for reverse the signal, and if you click and if you drag, you can add many signals. Here there is auto, no manual, and I can add one more signal for LT, the pump LT. Double click and give pump LT, HLTH5. See, now initially it's giving red color because you did not create it earlier, so it's giving red. Once you created, it will ask you to type select the types. I will give boolean and I will give OK, healthy. So if you see, now you added one signal, but you need to know that where it's added. It's added in the same place. Just check here, and it's added it's added in internally, but after you save and check the signal whether it is available in your data type. See, when you need to know that where the signal is added. Double click, make browse. In this pump, you can find this one in that near the timer, but it is in the private because you added directly from this place. Example, if you created from the derived function block as predefined as public, I will add one signal called pump E stop. Okay. Just I added pump E stop, save, and now click the pump type. Here you can add, you can browse the signal, and you can use the pump E stop. Okay, this pump E stop, emergency stop, if there is no emergency stop, so I need to put the negative pin for this. If you are using only 4 inputs, just click and drag, it will add only 4. So otherwise, if you need to add more, right click this function, go to these properties. So you can see here how many functions you added here. If you need to add the enable and en and unenable, just click, you can find enable here. Here you can give the link with another signal, or from the ladder logic you can make the link to enable this function from the left to right. For input, some inputs, additional input, if you need to make some logics, you can add in this enable. If you don't need to use this enable, remove this one, apply and give OK. So you make one small logic. From here you need to give example one output for this function. So I can give here, or I can make a link with this one, with this AND logic. So just make here, click the link, or use the F6 and make link between these two. So this logic is linked with OR. If any one of the logic is satisfied, it will come to this one. Here it will check both logic. If both logic is on, then only the execution of this pump will run. Here what I will do, I will add one function for input called pump. Here I can add, or you can browse, but currently we did not add the signal. So I can add first one signal for the input. Here, click, add one signal called SCADA auto, SCADA command. I added this input, so I can give the same here, or you can browse SCADA command. If this logic is satisfied with any one, example the pump is in auto or it is healthy, and it will come to this mode, SCADA command. So once the SCADA command and pump is auto, then it will execute the command. So this is the small logic we made for this, and I will use this one with timer. So what I will do after this, before adding this command, I will add with the timer. So once this logic executed, just click F6, function 6, or you can use this link to add, and you can add the timer hash so I can add the timer 30 seconds. Just give OK, and you can give the command. After this timer execute, after 30 seconds, the output will enable for the pump. See, this one small logic. Save this function, and you saved but still not rebuilt, so rebuild this function. Once rebuild successfully done, then close this block, and you can see now it's not trademark because you already configured everything. It's okay. So now you can create one pump section in the function block types. How you can use this function block type? Just click your logic. See, earlier you used one small logic, but I will add one more function, one more block, one more new section, and you can create either ladder, or you can give function block or anything, no issue. Just add function block diagram and give pumps and apply. It's created already. Double click the pumps, and you need to use this pump here. See, now right click and give here FFP type or data selection, and type directly PUMP and click OK. See, the pump which you created, it's automatically imported here. So this is one function. If you have 10 pumps, you can add the same 10 times, same block as 10 times. How many pumps you need in your application, you can add. See, this one which you created, everything is by derived function blocks. This one you don't need. See, here you are not addressing any of them because it's all general address. If you see in your function block instance, see, this is the general function block types you added as one time. Okay, this everything is general type. The same function block, how many pumps you are adding in your logic, that will be implemented in your function blocks, because you added 4 pumps in your logic, so it will come to you 4 times: pump 1, pump 2, pump 3, pump 4, or you can use here like this. So now you created 4 pumps. Okay, so if you added earlier for the 4 pumps here, example pump 1 underscore healthy, pump 1 and pump 2 underscore healthy, pump 3 underscore healthy, pump 4 underscore. Similarly you can give for pump 1 underscore run, pump 1 underscore, pump 2 underscore run, pump 3 underscore run, pump 4 underscore run, etc. And you can use for pump 1 underscore auto, pump 2 underscore auto, pump 3 underscore auto, pump 4 underscore auto. Pump 4 underscore auto, now I will add pump 1 underscore start command. Copy this one and pump 3 command, pump 4 underscore start command. So we added 4 pumps: healthy, run, auto and start command. So I can add here the signal pump. See, if you browse, it will come. Usually when you type pump, it will come to you pump all the pumps. But now we added, see, if you can search also in variables, pump 1, save, check. Used pump 1, healthy, run, everything is pump 1. So type the same thing here. PUMP1 underscore. So you can find all the pump. See here. Okay. Remove these things. Browse, see here, what is that one? Pump auto, pump 1 auto. Also here view did not add in manual, no issue. Add pump 1 manual underscore run, pump 1 underscore run, pump 1 underscore tray, see if you not add, just add and click. Similarly for the pump 1 underscore manual. pump, this one SCADA command, pump 1 underscore SCADA command. Just add, and here you can give pump 1 start command. So you can browse, or you can find here pump 1 SCADA command, pump 1 start command. Pump 1 start command. So you added here. If you need to duplicate, delete these things, copy this one and add and change only that time. Pump 2, just give OK. 2, pump 2 run and pump 2 trip, give OK. Pump 2 SCADA command and pump 2 start command. And you can add one more for pump 3, or you can copy both and add this block here. Add pump 3, pump 3 auto, pump 3 manual, and pump 3 run, and pump 3 trip, pump 3 SCADA, pump 3 start command. Similarly for pump 4 now, just give pump 4 auto, pump 4 manual, pump 4 run, pump 4 trip, pump 4 SCADA command, and pump 4 start command. So you created 4 pumps currently. Here if you see, you did not give any physical address of that. You can give, just you entered only direct address. If you need to add if you need to link with your physical address, give, this is the earlier we created now for the hardware address percentage 0.1.0 for the first signal, second, third, like that. Similarly you can add for those also with the physical address, but now currently I did not use any physical address, just for testing. If you have time, you can put the physical address and you can test also. See example, if you see here, you don't have this physical address here. See, it's connected with only these pump sections. If I will add for one pumps, example this one. Okay, earlier we completed with percentage I 0.1.3. So I will continue for first only for first pump 4, and first pump run is 5, percentage I 0.1.5, and I will give for pump auto 6, 1.6, percentage I 0.1.6, and for start command, because for this SCADA command I will give some temporary address, example percentage MW 300. Okay, so I given this is for, because this internal address, it is mapped between SCADA and our PLC, so I given memory word address. For pump command we used already percentage Q 0.2.0, so I will use the next one for pump 1. Pump 1 start command. %Q 0.2.1. If you see in your hardware, just save this application, and you can see it's already added pump 1 healthy, pump 1 run, pump 1 auto. Similarly for DO command, if you click BMX DDO 1602, you can find this address also, it's added already. See here, pump 1 _ start command. So your physical address is physical wire for the hardware is linked with your address. So you already added for one pump physically, and others you already added the tags. So save this application and compile, because it's still not built. So you need to build this application. See, now build this application, and it is asking to compile this pumps section. Yes, I will compile. See, you have 4 errors currently. Just we'll check what is the error. Okay, it is telling that the topological type is incompatible. Pump 1 run, this 4, it is telling that it is incompatible. So if you see the pump sections which you added here, here there is 2 types, topological and mixed topological state. I'm just compiling. Here it's telling that pump type is 00, but elementary variable topological type is incompatible, because I told on earlier itself, if the signal is connected with physical address, example physical IOs, it should be E Boolean. Change this one to E Boolean. E Boolean. Similarly for this address, E Boolean. So now save this application after you change the boolean, compile now. Build the application. See, now there is no error. So it's okay for us now to simulate the signals. Now we will see, now already we created the function block, derived function blocks, and we added in our logics. So now you already created this pump. Now I need to import and export the functions. See, just right click these pumps and you have option to export these functions. Click this function, export, and give the name pump _ export. Just I will export the pump. Okay, it's already exported this xdb file. Okay, now I need to import the some of the blocks I already have in my library. Okay, in my functions already we created in many projects, so we already have some functions, so I need to import that blocks, example analog scalings, or for walls some redundant pumps like this. So you need to be import that functions. Right click and you have option to import. It is asking you when you are do you need to confirm this modification? Yes. And you need to save this project. You have to give yes. Because before importing it will save the project automatically. So you can give yes. After that it will take little bit time to import the file. Now it is asking you which file you need to be import. I am going to import analog input. Just click import. It's added already. It's added analog input. And also I need to be add standard pump blocks and valve blocks also. This is one standard block, pump block. I will add that pump block also. It is asking that because you created the same name earlier, it is asking shall I keep this new name as pump underscore 0, rename, keep or replace. So you have option here, keep or replace. I will give rename. So I will give OK. It will be created as a new name. See here, pump underscore 0. So you already added one analog input, one pump, and this one we created earlier. So I will add one more function for valve. Here in this function for all analog input, analog output, pumps and valves, you can use in any application related with the Unity Pro. You can import in any projects if you require. So you can create at one time and you can use in many projects. See, now already added analog input, analog outputs, one pumps and one valve. Give save. See, this is my analog scaling. Double click the analog input and with analog scaling. You can see the scaling block for analog, and for the pumps, double click the pump section. See, this is my logic which I earlier created for the pump. Here I have for the pump auto, feedback, stop, overload, pump trip. Based on your requirement of the project, you can make this logic. If there is pump running, there is no fault reset, then after this 1 minute, it will take 1 minute to get the healthy, because the pump will not run on and off immediately. So we will put 1 minute time delay for that. So this is our block we added for one pump. See, after all this logic is satisfied, then only the pump will make a command. So this is my pump block. And similarly, if you go for valve, the valve command, if the one is in auto, and if there is open manual open command is already came from SCADA and there is no open fault, then it will give it will on this signal, because it should be satisfy all the signals, because it is AND function. So it will come here to operate this MOV. Otherwise it should be satisfy this condition or the third condition, this one. If any of the three AND functions is satisfied, here it will operate the MOV. See here, for closing the MOV also similarly the same condition, it is reversed. If this any of the condition is satisfied, so it will be close the MOV. So you have open and close. For the pumps usually you have only one command for start and stop. For the valve you have usually two commands, one is for open and one is for close command. So just you already saved, so rebuild this all functions. Even if you are not using these functions, you can keep here in derived function block, because it will not affect anything. See, there is no error, because even though you did not use, but it is already compiled and built. If you need to use in your application, first close all the functions. Now I will add one analog input. Already you added one analog input before, I think. Tank level, this tank level. So I will add this analog input function. So just click add new section. Give anything like you can add in function block diagram, or you can add in ladder logic or STIL, anything. Okay, just I will give analog, or I can give tank level. Okay, with the tank level. What I will do now, give the same input name here. Okay, right click, add, browse, or you can select from the analog input, add, and add your analog input signal called tank level, or browse from here. You can find tank level, and you can give minimum and maximum range. Example 0 in minimum. Okay, this is minimum and maximum input. 10 out max, output minimum 0, 10,000. And you can set, you can make the set point for low alarm, low, high, and also you can force the analog input also in this block, and the output will be here. It will come as, see, whenever you are creating analog input, it will take you here as analog input as integer, and output it will give you as real. So I can add one real value, percentage MW 320. See, because it's created, but it's created as integer, so you need to be give this address to real. See, it is integer. Go here, you already added here, na? Integer. Where is this one? Percentage M3 MW 20. Okay, instead of this one, first you can give the name tank real value. Here it will ask you to give real. If you need to give any address, you can give here %MW320. Add. See, it's already added. So this is the basic analog input. You created one block. Even if you need to modify and export, you can export from here. Just now we created the derived function blocks and we imported and exported and we implemented in our project. Now what I will do, I will just save this project and we will make a simulation now. Earlier in the first part I already explained about these connections. Again we will go here. See, before going here you need to see here. See, this is PLC. This tick mark is in PLC means it is already in the standard mode. If the tick mark in simulator means it is in the simulator mode. Usually when you install this Unity Pro, the simulator will be automatically installed by itself. You don't need to install additionally, and the default simulator IP address is 127.0.0.1 and it will be connect media to TCP IP. Now just click and select simulator mode. See, once you select, it will ask you, once you select, it will ask you confirm to change simulation mode. Yes, and you can see now, see, it's selected in the simulator. This means already your connection is in simulator mode. See, and also you can see here it is TCP IP and this is your simulator address. Once you connected, just save and compile. Compile. After you built this application, you can check. It's still not yet built. Build this application. Okay, now you are not running any simulator. So just if you need the procedure I already informed before. This is the connection: connect, disconnect, run, stop, and go to online mode. Transfer to connect from PC to PLC. This one is upload from PC to PLC to PC. Okay, this is the one you need to be utilized. Okay, currently see, and also you can make here standard mode or simulated mode directly here itself. No need to go here and use this things. You can use from here also. See, now you just give connect. See, it will open simulator mode. See, once it's open, you can find from here. See, it's added one simulator and you can find, you see it is different, no configuration, no upload information. So this is the identification that you already added the simulator and it is already trying to connect it with your simulator mode. See, if you right click, go to the simulator panel, see, you can see no configuration, no invalid. So I can keep here just because this is simulator. So you need to download your application to your simulator panel. So just add here and it will ask you, this is the similar procedure you need to use in your Schneider PLC also, in the physical PLC also. Okay, just check here, this is your project, this is your version and date. Just give, because this is the option, it will ask you after you translate this application, transfer this application to your PLC, it should be ask you to make the run mode or not. Therefore I click that yes. Therefore now we are transferring the application to your simulator. See, the simulator, see, it is blinking. You see it is blinking and it is trying to run, but still it is not run because you did not given to confirm to make a run. Okay, give run and see your simulator now. See, it's in running mode. This means now you connected with your simulator and the project is running. So you can see all the values is default, it's 0. And now go to your pump section. See, whenever you are going to your run mode, you can find everything in green color. This means it's already running your application in online. So click this one and you can find, so click backplane or power supply. See, it is showing everything green. This means your backplane where it is showing some warning. Click this one. So you can see here the task for the current situation. It's 250 watchdog and it is running mode and command stop disabled, and you can see the real time of the PLC, and this is for your PC, and you can see the informations also. This is PLC simulator and this is the processor version, hardware ID, and this is your network ID of the simulator. Even you can see the memory, identification, options, last modification, miscellaneous, everything. Usually when you connect with your physical hardware, you cannot find this type of red color error because you are connected currently, you connected with simulator, so it's showing that it is not compatible with simulators. It will not affect you anything for testing your logics or anything. No issue. See, this condition now it's currently it is reset because these conditions are not satisfied in your logic. We will move to the pump section. You will see here. See, now I will make to start one pump. See, initially I will give run. Here go to initialization. See, you have options here. Initialization, animation table. If you click, it will go to animation table directly. This is temporary. If you need to save this one, save this animation table. It will save you the animation table as new videos. So you can force from here also. One way to force the signal. You can force from animation table or you can force directly from the logic itself. See here, just give one. See, it's all one. See, the signal pump on is on. If you need to know when the logic will execute, right click, refine, and you can find, see, up to here it's okay. But I told you earlier, any one of the condition is satisfied, it will go to the next level. Here SCADA command, it requires signal. So you need to go here, give SCADA command. Either you can go to animation table or you can right click and set directly from here. See, I set now. You can see now your block. See, it's running and now it is counting the timing. So your logic is satisfied and it's waiting for 30 seconds. Now already 15 seconds completed. After this 15 seconds, the pump will start automatically. See, now maybe just wait for 5 to 10 seconds. The pump will start automatically. See, now the pump is started. So this is the one you need to be test for the pump sections or any other sections through forcing the values, or you can make the force by in animation tables or by directly here itself. So the pump is started. So once I give the pump command off, it will be off automatically. Either you can give here or you can give in the animation table. See, I will off here. Set to 0. Okay, here also. It's off, but the pump is still running. Okay, because you given the start command, this pin is continuously running. So you can troubleshoot this one, why it's continuously running. Because we mentioned earlier, any one of these on, it will be on automatically. I will force this value, set to 1. Because you use this one by timer, so after this 30 seconds it's continuously on, and also this one is latched continuously. So this is the basic how you are going to check the logics. So you completed now the simulation part as well. Now we will move to the I/O sections. Just what I will do now, I will just disconnect the simulator. See, now we already completed up to the derived function blocks and how we will import and export, and we check the simulator. So now we will move to the district I/Os. Here what we added here, everything is local I/Os, because this everything is connected in one I/O. Okay, so we are telling this one as local I/Os, because in the rack itself it's added everything. In case if you need to add one more rack here, just add one more rack. Sorry, actually I am using virtual machine. Sometimes the virtual machine, it will open the black screen. So I will add power supply. See, it will not ask you to add your CPU, because already the CPU is added here. It will ask you directly to add the communication card. So I will add the communication card. And you can add some I/Os here. For your best practice, you don't need to add all your local or distributor remote IOs in the same CPUs, because this CPU which we use is M340. M340 you have some limitations and you cannot use for redundant or some more than some IOs. Example 2048 IOs we can use for M340, and if you use more you need to go with M580 CPU. So if you go for the M580 CPU, have redundant functions and it's having high capacity of IOs, and also you can use for remote IOs, distributor and everything. Even you can use here also for extenders, and also you can use for some functions in M340. You can see the architecture in for each PLCs. You can check the architecture as well and supporting modules also. So for best practice, see here you have PLC. See, you can add only here for extension or adding these remote IOs. Okay, if you need to go with EIO or here for distributed IOs, if you need to go for remote IOs, better you need to use M580. Just what we will do now, we will create one simple application. I will close this application. It will ask you to save. So close this application. Just open, create new, or I will show you our example itself. See, you have M580. I will open M580. If I create, it will take little bit time, so I will explain from here itself. See here, this is local and this is EIO. See, in local you created one CPU. See here we used the M580 processor. Here we use some DIDO card, and we used here EIO bus. Okay, here also they did not complete it. What I will do, I will add from here. See, here you have remote drop. So add the remote drop. I think it is not able to add because this is in read only mode. Better I will go back. I will open one sample application. Or I will create one new application and I will show you how to add the local and remote drop. New. M580. I will use hot standby redundant CPU with, see here itself, as I told earlier. See here itself you can find that this one, it's not supported remote and distributed I/O, but it will be support only the extended I/Os from these modules, from this CPU. For this CPU, if you see here, this one is supporting both remote and distributed I/Os. And some of the CPUs, if you see here, it will be used only for distributed I/Os, not for remote I/Os. So what I will do now, we will select this CPU. This is all done by CPU. See, when you are when you created itself, it will come to you remote also. Okay. So here it's automatically select the CPU, power supply. For time being, I will not use everything. EIO bus in the CPU itself. It is asking to see, it will be connect directly with this EIO drops. You can connect directly to the EIO bus also. So now just I will add communication NOC module for Ethernet communication module. Just I will add one NOC module. And I will go here to add Ethernet IO, this remote IOs. Double click. See, here you have option for remote drop, quantum remote, and S908 remote drop. So I will go remote drop. I will select any one of them. Okay, I will select this C8 slot. See, in the local drop, you can use these modules, what they mentioned here. In the Rio bus, you can use this Rio bus drop. You can find what are the modules it will support for you. See, now when you created, it will create automatically the CRA module, because the CRA is the one will connect between this primary and this Ethernet remote IOs. So just I will add power supply 3500 and I will add some IOs. So you can find from here itself what are the modules we will support for the remote and IOs. From, see, here in the hardware catalog, usually it will show you this is a local bus, PLC bus. What are the hardware it will support, you can find from this list itself. For the remote IOs bus, you can see from here, see 800 IQ drops, remote IO drop for quantum. Even you can add the rack with quantum IO rack also. See, I will add here quantum IO rack. I will add 6 slot. So when you are upgrading your project from older to new project for upgradation, you don't need to remove all the modules. Maybe you need to change only the CPUs. The example, you need to make the processor, ICE processor, and with latest versions. Just change only the CPUs, upgrade the CPUs, and keep all the IOs remain same. So you can add the IOs from here. Add some IO card. So you can add all the IOs. Even if you need to use different concepts, example with remote IOs, with see this remote quantum and S908 remote drop, or you can use from the previous same backplanes you can use, but you need to check before you are configuring. You have to check the manuals which is supporting and how much maximum racks you can add. And even you see here, you can give extended rack, add extended rack. See, whenever you are asked, it will ask you to remember that you need to be add the hardware part for that, because this rack extender kit is very important to connect between these two racks. So this is the one it is telling you to remember that use that extended hardware kit. Ethernet connector of these racks are disabled because the rack is not in primary position. So he has to give OK, and you can add here the IOs also. See, you can add your IOs. So this is the one we can add all the local IOs. Even from the local, you can see here in the local also you can add here rack and select and put 8 slot example. It will be create here also. This is local rack, and which I am using here, which I am creating here. This is for local, and which we used here remote and distributed called EIO, which we used here. So we already checked almost all the parts in the Unity Pro, such as basic configuration, hardware configuration, IOs. After hardware configuration, we make the variable. We created some variable list, and we created the communication part and the basic programming part. And in the part 2, we connected the we make some function blocks, and we added we imported and export the functions, and we created the simulators. We simulate some signals, and we connected with the simulator and import and export the functions, and we checked the remote, local and distributed IOs as well. And on the next part, we will connect with the direct physical hardware, and we will test some other parts, such as some advanced function levels. And also in the last section, we will check how to import and export the libraries. So again, we will go for our own project better, because this project we did not import or export in this library because we used earlier. So I will go to that one. I think this is the one, test. Sorry, no need. I will give this one as hardware. So I will open that old application which we created earlier. From there, we already import and export the functions. No? Just we need to see where it is stored and how you can use in your library. So if you know the Unity Pro, so you can understand at least the basic concepts, no? Because you need to know that how to configure the hardware, how to configure the IOs, how to add the IOs, and how to link with the hardware, and programming part, basic programming language and functions, and also how to import the blocks, projects, and also how to make a simulations and how to connect with your PLCs and everything. because this is the similar for all the PLCs, not only for the Schneider. If you go for Siemens, Rockwell and or any other branded PLCs, you can use the same formula to connect the PLCs and also for making the logics, but the structure is little bit differ, but the concept is same for us. So here we already created this analog input, analog output, pumps and valves function blocks. Now I need to import everything in my library. Okay, just here itself, if you click, right click this one, put in library, add this one. Okay, it will ask you in the custom library. Earlier I told you that in default you need to be use this custom library. Click and give OK. Give OK for each one, add here in the library itself. So you need to select the family. So you just go inside. Even if you need, see, add here, pumps, and also you can add these three. I will add currently these three functions in my library. So in your application, whenever you are using the Unity Pro in the same laptops or computer, you can find these three analog input, analog output and valve in your library itself. Put in library. I think already I put. Okay. See, whenever you are going to your library, see it will come to you the same. Analog input, analog output, valves, everything. See valve. Okay, even though if you need to go here, go to types of library manager, open completely, check in your custom library, see this library, already it's added in your library. So if you add one time, until you are not formatting your laptop, your Unity Pro, it will be remains in your Unity Pro itself. So I think we almost cover the applications, complete Unity Pro. On the next section we will go with still depth programming parts. Maybe we can go with ladder logics, depth on ladder logics, instruction list, structured text and functional block diagrams, and as well as SFC, sequential flowchart, or graph set language. So thank you for watching this video. You will see on the next video. Thank you.